Hello friends, welcome to our channel. I hope you are all in a very good health and studying well with your full focus. Thank you for joining me. Today we are going to discuss about the image formed by a concave mirror. We have already discussed three cases. Today we are going to start it from case 4 where the object is placed between center of curvature and focus of a concave mirror. So let us see the ray diagram. And the dark part is our reflecting surface. This is our principal axis. This is the pole, this is focus, and this is our center of curvature. So the object is placed in between C and F. Let us name it AB. Two rays coming out of this point. First ray, which is parallel to the principal axis, after striking the mirror it goes another ray which is passing through the focus. So this is our first ray. The direction of the first ray is shown by arrow 1, and the second ray is passing through the focus, and after getting reflected by the mirror it becomes parallel to the principal axis. So we can see the two reflected rays intersect at a point where if a screen is placed we can get the image of the object. So let us name it A dashed B dashed. This is our object. This AB is the image, AB is the object, and A dashed B dashed is the image. AB is our object, okay, and A dashed B dashed is our image. So when the object is placed between C and F, The image is beyond C. The image is formed beyond C. Okay. This is a real image. Inverted with respect to the object, and the image is magnified. So these are the properties of the image. Now case 5. When the object is placed at focus. This is our concave mirror. Pole. This is the focus and this is our center of curvature. Let us assume this is our object AB. Two rays are coming out of this point. The first ray is parallel to the principal axis and it is passing through the focus. And the second ray is when the second ray, okay, let us assume the second ray is moving in the direction CA. That means the second ray, when produced backwards, passes through the center of curvature. Okay, so the second ray comes out of this point. The second ray coming out of this point strikes the mirror and gets reflected, and we know When this ray is produced backwards, it passes through the center of curvature. So the second ray will follow the same path but in backwards direction. We assume that these parallel rays, these are parallel rays which are going to intersect at infinity. Therefore, we always assume that two parallel rays meet at infinity. So the image is formed at infinity. So the nature of image, number one, the image is formed at infinity. As the two parallel rays are meeting at infinity, therefore the image is a real image. Number three, it is inverted, and the image of the object will be highly magnified. So you need to remember these points. Now let us proceed to our next case. Case 6. When the object is placed between the focus and the pole, Now the object is placed between F and P. Okay, this is our object. So let us take a point on the object. From that point, two rays are coming out. The first ray, let us assume the first ray is parallel to the principal axis. So after getting reflected, it passes through the focus. And let us assume the second ray strikes the pole. So after getting reflected, so we can see that these two rays are not going to intersect, and they are not parallel. Now if we produce the reflected rays backwards, they will meet at a certain point. These two rays are not actually intersecting each other. So when they are produced backwards, they intersect at a point. So at this position, we are going to get an image of the object. So this is our object AB, and this is our image A dashed B dashed. So when the object is placed between F and P, the image is formed behind the mirror. This is a virtual image. This is upright with respect to the object. And the image is magnified with respect to the object. So these are the properties of the image. So we have discussed about 6 cases, and this is the only case where we are getting a virtual image. But in all other cases, we are getting real image. Now we are going to discuss image formation by a convex mirror. So in this case, we can put the object anywhere in front of the mirror. The object is placed anywhere in front of the mirror. So let us draw the ray diagram. So this is our silvered surface, and this is the reflecting surface. This is our convex mirror. Now let us put an object in front of the mirror, and let us consider one point. So two rays are coming out of this point. The first ray, which is parallel to the principal axis, and after getting reflected, the reflected ray appear to come from the focus. So when we produce it backwards, it passes through the focus. And a second ray, which is directed towards the center of curvature, okay, another ray which is directed towards the center of curvature, after getting reflected, follows the same path, but in opposite direction. So when the reflected ray is produced backwards, it passes through the center of curvature. So now we can see, when the reflected rays, okay, this is our first reflected ray and this is our second reflected ray. When the reflected rays are produced backwards, they meet at a point. So here we are getting an image. The image is virtual, it is erect or upright with respect to the object, and the image is diminished. That means the size of the image is smaller than that of the object. So these are the properties of the image formed. As the object comes closer to the mirror, the image shifts from focus to the pole and increases in size. So you can remember this point: as the object comes closer to the mirror, the image shifts from focus to the pole and increases in size. Number 1, it can be used as a shaving mirror. When we hold a concave mirror very near to your very near to our face, then our face lies between the pole and the focus of that mirror. So a virtual and magnified image can be seen inside the mirror, which helps us to properly see the tiny hairs on our face. For this, we can use a concave mirror of large focal length. So it is used as a shaving mirror. Now, point 2. It is used as a reflector. Reflector in torch, searchlight, headlight, of cars and other vehicles, where a concave polished metallic surface is used as a reflector. And the object is and the source of light is placed at the focus. This helps us to get a parallel beam of light. So this can be used as a reflector. Okay, so in this case, if we draw the diagram, this is our concave mirror, this is our pole, okay, this is our focus, this is our center of curvature. So the source of light is placed here at focus. So when light rays strike the mirror, they become parallel to the principal axis. So this kind of a mirror help us to get parallel rays of light. Now number 3, it is used as a dentist's head mirror. It can be used in solar cookers and furnaces. By focusing the sunlight on a very small area, concave mirrors can generate high temperatures for cooking or heating, etc. Number 5, it can be used in reflecting telescopes. So these are the 5 uses of a concave mirror. Now let us discuss about the uses of convex mirror. Number 1, it is used as a reflector in street lamps. Number 2, it is used as a rear view mirror in vehicles. Because it provides a wider field of view as compared to plane mirrors, allowing drivers to see more of the traffic behind them. So this is our plane mirror M, and let us assume this is the driver D. So light rays come and strike the mirror and get reflected, which is seen by the driver. Similarly, another light ray is coming and striking the mirror, and after getting reflected it is seen by the driver. So the image is formed behind the mirror. This is the image I. So when we use a plane mirror, this is our field of view, and when we use a convex mirror, so let us assume this is our convex mirror. So the first light ray is coming and striking the mirror, and it gets reflected and it is received by the driver's eye. And a second ray is coming and striking the mirror, and after getting reflected by the mirror it is received by the driver's eye. So the driver can see the image of the object at this point. If these reflected rays are produced backwards, they meet at a point where we get the image, and this is our driver D. So we can see that in this case the field of view is wider, wider field of view, but the image is closer to the mirror as compared to the plane mirror. That means in plane mirror the object distance is equal to the image distance, but in this case, in the case of convex mirror, sorry, in the case of convex mirror, the image formed is nearer the mirror. So when the image is seen through the convex mirror, it appears closer. The object appears closer than its actual distance. So this is the second use. Now let us come to the third use. Security mirror. Convex mirror are widely used in stores, ATMs, showrooms, and building entrances for surveillance purposes. The wider field of view allows a single security personnel to monitor large areas efficiently. So it can be used as security mirrors. It is also used as road safety mirror. Convex mirrors are installed in sharp turns or hairpin turns, you can say, or blind spots. Intersections and exits to improve visibility and reduce the risk of accidents. You might have seen it installed at different places on roads. It is used in street light reflectors. We have already discussed it. Okay. It can be used in optical devices such as ophthalmoscopes. So these are the 5 uses of a convex mirror. That's all friends for today. Tomorrow we shall come with another video. In our next physics class, we are going to discuss about the mirror formula and the deduction of mirror formula and the sign conventions related to mirror, spherical mirrors. We are going to talk about magnification and we are going to solve some numericals related to that. Thank you friends for today. If you liked my video, please like, share and subscribe. Thank you.